if you're seeing my screen, you're seeing sketch a graph of the function, make a table of values, and evaluate the function for each of these values here. So, these
All
values.
right.
Okay. So I don't really feel like they have enough room here, but we can try here. So the thing here that most students don't remember is that when you substitute for a variable, you're substituting in parentheses. So what I mean by that is, and let's do it for one first, because I
Okay.
think this will make more sense. So it's minus parentheses 1 squared plus 5.
+5.
So see how this like x is really in parentheses, even though it's not shown that way. It's like I use this word implied. It's implied that it's there, but now you got to know it. You got to know that that's the case. So order of operations says you square first, then negate. Square
Mhm.
first, then negate. Okay, so that's -1 plus 5, which is
6.
4. -1
Oh.
plus 5.
Oh, right. My
All
bad.
right, and I actually have this in the wrong place. Let's get this down there. Okay. So now for 2, it's the same deal. You square first, because it's in parentheses here, and you do exponents first. So the value you substitute is in parentheses. It's always in parentheses. Like think of whenever you substitute in for a variable, you put it in parentheses. It will save you a lot of uncertainty about how to do this. So you square first, then negate, and that equals 1.
All right. Wait. Why is it like negative before the parentheses? Like, is that just in the problem?
That's
Like,
that's right up here.
oh, okay. All right.
Yeah. Okay. So like let me just come off to the side here, because I think this isn't really the best example of this. Let's say it's x plus x squared minus x cubed.
Okay.
Okay. And I want f of 1. So wherever I see an x, I'm putting that in parentheses. Do you see that over here on the right?
Mm-hmm.
And I don't need it there. I actually don't even need it there. But it's like you overdo it just to like really emphasize that it's in parentheses. When you substitute, it's in parentheses. Because then you don't make these mistakes of like figuring out, what do I do here? So 1 cubed is 1, and you get the right answer there. Whatever it is ends up being 1. Now let's do f of -1. Okay, so back up here. All right, so back up here. So it's -1 in parentheses plus -1 squared minus -1 cubed.
All right. So then, would it? You just
So now you don't need the negative. You don't need the parentheses because there's no operator here. So the parentheses holds it until there's an operator. So there's no operator, so you just leave it. On this one over here on the right, you square the -1 because it's in parentheses. So it's effectively like multiplying -1 times -1, which is +1.
yeah.
Okay. Here, it's -1 times -1 times -1 3 times. -1
-1,
times
-1.
-1 times -1. And that produces -1, but then you have a negative here. So it
Right.
becomes
I'm positive.
+1. It becomes 1 again. So the point of all this is that when you substitute for a variable, you should put it in parentheses. Okay, and that's what we were doing down here. There was a negative always out front, but you substitute in for parentheses.
All right. I guess that makes sense. So,
We're going to do more here. So this one, like the function, I'm sorry, it's not clear here. The function, let me just rewrite it so we can see here. Your function that you're doing is -x² plus 5. Okay. So let's do 0. I know we're doing this backwards, but there's a reason for it. So you put a 0 wherever you see an x. So it's minus parentheses 0 squared. You always put that value that you're substituting in parentheses. Okay, so 0, go ahead.
so you would so would it just be like 0 plus 5?
Yes.
Okay, so then just 5.
Yes.
All right.
Okay.
Yeah,
Again,
I guess there's no such thing as like -0. So.
well, that's not completely true, but for in computers there is such a thing as a signed 0, which kind of doesn't matter in this context, but it is possible. So
So I guess that would be if there's negative and then there's the 2, it'd become just positive 1, but since there's the negative outside, it would be negative 1 plus 5 equals.
You said that perfectly. Yeah.
Okay. All right. So
And-
then I guess for that one, negative 2 plus 5. So then I guess it would be a positive 4.
right. And
And
then
then use the negative. So then it would become negative 4 plus 5, which equals 1.
yes. Okay, so the ordered pair, and this, I don't really like this, but this is what it is. It's x comma f of x. And what it means is you take the number you started with and the number you produced. Okay, so it's the number you started with, that's x, and then the number it produced, that's y. This is really y. So in other words, f of x is the same as y.
Okay, so
So
f of
this could be y equals minus x squared plus 5. And it's
x equals y. So then negative 2 and 1. So then I have to write, okay, so
so you have to write negative 2
like
comma
f.
1.
Okay. So
So we're gonna do another one here. So what's
all
the
right.
x value?
The x value is negative 1.
Negative 1 comma. What's the y value? The y value is the output.
4. Okay, so like the input and then output. Oh, okay.
That's right.
All right.
Input's x, the output is y.
Okay, so then I guess 0 and then 5,
Good.
and then 1 and 4, and then 2 and 1.
Yes. Okay, so the next part of this is to graph it. Now, if you do it in these pieces like we've been doing, you have a chance here. So let me snip in. Let me snip in the graph here. Okay, so we'll do this stuff on the left later, but let's graph the points. Okay, so we're going to graph minus 2 comma 1, minus 2 comma 1.
All right.
Okay, minus 1 4.
Should I label these when I actually like if I were to do this or no?
No, just getting it like, because you're gonna you can get the intersection of these points. That's a good question though, like, because you're probably used to labeling them. The key, because you're labeling, you've got so many, that's why you don't label them. Now this has an upside down U shape.
Mm-hmm.
Okay, horseshoe shape.
Somewhere in my notes was it can never go up, or was it like can the never go up or down? Like I can't
Well,
remember.
it either goes up or down,
Okay.
but it's this U shaped.
It's always in a U shape going up or down.
It's either a U up or U down. And see, that's not important what yet. Like, this is a little bit out of scope for your class. They should be giving you lines, but they're not. So,
Okay.
we'll do the best we can here with this. All right. So vertex, this point up here is the vertex. The vertex is either the max or the min. So it's the max when it opens down. Do you see how this opens down?
Yeah.
Or the min when it opens up?
Max down or min up. So
it's this point at the top, or it's the point at the bottom if it were to open up.
oh, so that's the vertex. Okay.
Yes, the vertex is 0 comma 5.
0 comma 5. And then I guess the y-intercept would be also 0, 5.
Yeah, this is where does it cross the y-axis?
All right. Axis of symmetry.
Yeah, so there's a line. If you were to cut this right down this place, and it does happen to fall on the y-axis, but it's the x value of 0. The x is always 0 along this line. This is a little bit, again, kind of out of scope for what you're doing, but think of it as like if you were to cut this in half so that each side was exactly the same, where would you cut it?
Okay, you just cut it on like 0.
0, yes.
And
Because
then
because
if it
x
was
equals
like,
0 is a vertical line. Let me do that in you had a question there. I'm sorry.
oh, so like if it was moved over, let's say like this thing was moved over like by 3
Well,
cubes.
let's say it looked like this. I'll just draw another one here.
All
This
right.
one opens up. So see, this is the vertex there for another
Mhm.
one. What is its axis of symmetry?
-5.
Yes. So
So
it
would I
would
just write like x equals -5 for that?
exactly. Yeah, you've got
Okay.
this. You've got this. This is x equals -5. Okay. So your domain for parabolas is always minus infinity to infinity. Have you seen that? That's an interval notation. You can say no. I don't know if you've seen this. There's different
Um,
notations.
I don't think I've seen that.
Okay. So the other possibility here is that your instructor is saying x is an element of the real numbers.
That looks a bit more familiar.
And then they might have added a set like this x such that x is an element of the real numbers. Is that maybe what you saw?
Yeah, that seems more like it.
Okay. You want to get comfortable writing this, but you don't necessarily need to understand it at this point.
Okay.
Okay. All right. So the range has two options, and it depends whether it opens up or whether it opens down. So the range is y such that, and if it opens up, it's y greater than, and we figure out the number here. And if it opens down, it's y such that y is less than or equal to some number. So does this one open up or down?
Um, this one goes down.
Goes down. So it's this bottom one here. So this says y is less than, and you have to find the biggest number. And guess where this number occurs?
Uh, at
At the
the
at the
vertex.
vertex. See, the vertex is the biggest number that it can take on. So what's the y value there at the vertex?
Um, the y value looks like it would be 5.
5. So this is y such that y is less than or equal to 5.
All right, less than or equal to 5.
Yes.
All right. Um,
So we should do another one just like this, in my
yeah, I think
opinion.
that
In
would
my
be good.
opinion, unless let me look at what you sent and just see if there's anything else here. You just sent those again. Yeah, let's do another one of these, and we'll do it really similar to this. Okay. All right. Let's do. Okay. Let's say f of x equals 4 minus 2x squared. Okay. And we're going to make a table. Here's x. And then here's f of x. Now I'm going to tell you the values to put in. All right. Now, when you do this, we're going to do these down here first because these are easier. Okay. We're going to put 1 or 2 in first.
All
When
right.
you substitute in, it's best to assume that there's like parentheses here. So for 2, it's 4 minus 2 parentheses 2 squared. Do you follow that? See how that x, I put that value in parentheses?
Yeah.
You have to do that, in my opinion, if you want to understand how to get the right values. If you try to shortcut it, you may end up getting the wrong sign on something that you're doing.
All right. I'll keep that
Okay.
noted.
Okay. So now, order of operations. What do you do first here? Do you
You gotta
square? Do you multiply? Do you
multiply.
subtract?
You gotta multiply the
Nope.
2
Nope. You got to
squared.
square. You got to square. Yeah. So 2 squared is
4.
4. So
Then,
I'll write it out for this one. It's 4 minus 2 times 4. Now what do you do?
then you gotta multiply -2 and 4.
Okay, so that's 4 minus 8, and that equals,
-4.
okay. So see if you can do the next one here for me. See if you can
All
do
right.
1.
4 minus 2 parentheses 1 squared, and then equals 4 minus 2 parentheses 1 equals 4 minus 2 equals 2.
Good. Okay, so see if you can do it again for 0.
All right. 4 minus 2 parentheses 0 squared equals 4 minus 2 parentheses 0 equals 4 minus 0 equals 4.
Good. Okay, now the negative ones are no different, but you have to put them in parentheses. If you didn't do the parentheses down here, you would still get the right answer. Maybe. I assume you would. But if you don't do it here, there's a chance you could get it wrong. So that's why you have to do it in parentheses, because whenever you square a negative, you get a
Positive.
positive. This is 4 minus 2 times 1, which is 4 minus 2, which equals
2.
2.
All right. Yeah, this makes a lot more sense.
Okay, so I'm just finishing up the last one here, because the next thing I want you to do is I want you to write the ordered pairs. Okay, ordered pairs. Now, were you keeping notes, or do you want me to scroll up to the previous part when we do this? It's okay if you did. I just need to know if I need to scroll up or not.
I have a little bit, but might be
Okay,
able to
so let's go take a look here. Why did we come up with the ordered pair minus 2, 1 from this line here? Tell me in your own words how we came up with minus 2, 1
So
for
we
it.
saw what the input was,
That's right.
and that will become x, and then for y, you'd have to solve the equation, which eventually leads you to 1.
Very good. So down here, we're doing the same thing. The ordered pair is x comma f of x. Okay. So what is f of x? F of x is your y.
Um,
It's the output.
all right.
So what was
So
your
it's
input?
-2 or parentheses -2, -4.
Very good. Give me the next one.
Parentheses -1, comma 2.
Now you don't have to tell me parentheses, believe it or not. You can just say the ordered pair 0 comma 4, because I know when you say ordered pair to do that.
Ordered pair. Okay, that's it. All right. Ordered pair 1 for x parenthesis comma 2.
Yeah, so it's already implied that it's 1. Like maybe your teacher's being weird and telling you to say weird things, but if you just say, hey Matthew, it's the ordered pair 2, -4, I know to write this.
All right.
Okay, so it's like that special math speak
The
that we've been.
language of math.
Yeah. All right. Do you have any graph paper?
I do. Do you want me to go grab that?
No, we'll just do it here. Just if in the future, maybe just have some handy. I don't know how much graphing we'll do, but we're gonna graph these points. Now I'm gonna do it on. I'm actually just gonna go grab this again.
Okay.
This is one of the nice things about this format. Sometimes people are down on it. It's like, wait, we can do kind of cool stuff here. So
Yeah.
let's graph these points. -2, -4. So it's kind of hard to get, but there it is. There's -2, -4,
Yeah.
and then -1, 2,
-1, 2,
and then 0, 4.
0, 4.
Okay, and then the other points end up being here.
And then that is a upward or upper
It's opening down.
opening down.
Yeah, it's opening down.
Oh, right. Yeah, it's going like down. I don't know why I was thinking like the arch, if it's like going the top. I just have it like flip-flopped in my brain. I don't really know how to word it.
That's fine. So what I'd like you to do here is fill in this as best you can
Okay.
on the left side there from this information. And I can scroll up if you'd like to look at the previous one. You tell me what you want.
All right.
Excuse me.
Scroll up super fast, I
Okay.
guess.
Okay. So remember, this red one was just an extra thing. Try to
Mhm.
remember why we chose all these,
All right. I
all
think
this
you can
stuff
scroll
here.
down again. Or you can scroll down
Okay.
again.
All right.
Yeah.
There we go. So take
So
60
first
seconds. Take
60.
60 seconds to see if you can write it down on your own here. This is the independent portion of the lesson.
Okay. Is there a faster way to like say Y-intercept that's like considered normal for
No,
like a
just you're just going to give me the order pair. You say that you'll say the y-intercept is whatever it is
okay.
blank comma blank.
Um, could you scroll up super fast, please?
Absolutely, absolutely.
Oh, right. Okay. All right. You can go back down.
Okay.
Um, I might need you to scroll up again.
Sure. That's one of the limitations of this format is not being
Yeah.
able to get as much of it as you need.
Um, is the like up and down part you have that's part of the range, right? Not the
That's
domain.
the range. That's the range. Yeah, the domain is the same for both of them. The domain is always that for these questions.
Okay, so like the domain's always the same as the range.
No. The domain is always all real numbers. It's always this for
Oh,
these.
oh, okay.
Yeah, it's one of those you don't have to think about because it's just the same each time.
Um, all right. Oh, right. Okay. Could you scroll down real fast, please?
Sure.
Okay, go down. All right. Now I'll need you to go back up real fast.
All right, I'm gonna jump in here. So here's the vertex. The vertex is 0, comma 4.
All
That's
right,
the
I got
vertex,
that.
and this
And the
opens.
y is 0, comma 4.
It is also 0, comma 4.
And
So
then 0 for axis of symmetry.
now you have to say x equals 0.
Oh,
It's it's
x
it's
equal. All
it's an
right.
equation of a line. It's not probably emphasized that way, but it is.
AOS must have x equals number. All right.
Okay, and then the domain is this x such that x is an element of the real numbers. They might be using that symbol. I don't know what they're using. The
Yeah.
range is y such that y is less than or equal to 4 because it's that value there.
Less than equal to 4. Okay. And it's like that because it's going down, right?
That's right. That's right.
So I'm still a little bit confused on like why the domain's written like that. Like, why do we have the domain kind of like that?
It because your instructor is choosing. So there's two types of domains. Let me come down here. So domains are written in two notations. One is called set builder, which sounds to me it sounds really weird, and the other is interval. And like I don't know how to make an analogy, but like the analogy I'll make here is like set builder is like counting, and interval is like adding. Like we want you to be here, but for some reason they start you at set builder.
Okay.
And like they're like, oh, and then by the way, there's
Another way to do it. Um, set builder. All right.
okay,
Wait. I
so
guess like
all
maybe like one more time explain for like just the domain thing. 'Cause
so all real numbers mean it is written this way: x such that x is an element of the real numbers. And let me type it here so you can see it as well.
all right.
X such that x is an element of the real numbers.
Okay.
And
X.
and, and that's how you read this here.
X. Element.
May I ask, have you taken any classes as part of a religious thing that you've done, or any other schooling you've done?
Um,
Language classes, like,
I did Kumon.
okay, I'm talking about like Latin
Oh,
or like the Torah, some stuff in there,
I've
like,
done a bit of like Spanish classes, I guess.
okay. So there's all these like symbols in math and they mean something. It's like you see the symbol and you read it, like it mean like this vertical line means such that. This E right here means element of. That R means real numbers. Like there's a and maybe that's like a Spanish, kind of like your Spanish. Like you say donde está, right?
Hmm.
That's where are you, I believe. Right.
Yeah, that
So
is.
somehow like this is that and that is that. Like I don't know. Like that's what this is here. That's the equivalent of it.
Hmm.
So you just keep that in mind. I don't think they should teach it, but they still do. Intervals way less confusing, but that's you just have to know to do this.
Okay, I guess eventually I'll figure out how to get that done.
Yeah, you'll just it's like remembering your phone number. You just have to get it down. If you're still doing that, I don't know if people even remember their phone numbers anymore.
Yeah.
All right. So I think we should do this for an exponential. What do you think? What do you say?
Yeah, I think that's a good idea. I think we should try that out.
All right. So um, let's say that f of x equals 2. Let me do it. Actually, let me not do that. Let me do minus 2 to the x plus 1. Okay. And this time your table will be -2, -1, 0, 1, and 2.
All right.
So let me actually move this over here a little bit. This is your
I'll start
x.
solving that, I guess.
Say that again.
I'll start solving that.
Yeah, I'm going to help here though. Let's start down here. So the first one is
Wait, so you
negative.
like recommend starting with the positives first?
Yes, yes.
I'll do that.
Okay, so it's -2 to the power of 2 plus 1. This is different than what we were doing before. Here you square first because the value you substituted in for is up here. And up, it's not this base. So you're gonna do this and then negate it. Do you follow that?
Yeah.
Okay. So try it for 1 and let me know what you get for that.
Okay, so like when the x is like tiny like that, almost like if it would be the square thing, I'd put that number up there.
Yes, exactly. And you can put it in parentheses, but because it's positive, it's not as critical for that.
1 plus 1. So I guess 1 would be -2 plus 1, which equals -1.
I agree. How about for 0?
0 would be just -1. Oh, wait.
So
No,
it's -2 to the power of 0 plus 1. You
yeah,
do
it'll
this
just be
first.
-2 plus 1, which is
Anything to the 0 power. So any number to the 0 power is always 1.
okay,
So this is really -1 plus 1, which is
which equals 0.
okay.
Okay, any number with what was it called again? X to the
Any number to the power of 0. You're seeing my screen, right?
yeah,
Okay. Um, any number to the power of 0 is always 1.
always.
Okay. And then 1 to any power is also always 1.
Wait, what's that number next to the one?
It's an n. So
Oh,
like
okay.
1 to any power is always 1.
1 to any power
Yeah.
equals 1. All right. 1 to any is always 1. All right. got that one.
Okay, so this is where it gets a little bit tougher. So we need to go through just another rule here. So a number to a negative exponent is 1 over x to the positive of that exponent. So let me try to explain that here. -2 to the power of -1 plus 1. So this right here, this 2 to the -1, that's this rule over here on the right. Okay, so here, let me show you the result. It's 1 over 2 to the power of 1 plus 1. So it becomes -1/2 plus 1, which is 1/2. We're going to do a few more of these, but I had to eventually, get this in here. So
All right.
maybe we should do it sooner than later, but
Okay. I guess I get why it's like 1/2.
yeah, it becomes that, and the negative just comes there with it.
All right. Like I definitely haven't done that in class. Yeah, just like that -1 kind of example like that.
Mhm. So the thing is it said on your sheet here that it could be exponential, so that's why we're doing it.
Okay.
I really try not to do things like out of scope, but
Mhm.
I figured
Yeah,
we're gonna have
sometimes
to
it's, worth it. You'll be doing it.
get to it eventually.
And then is there any other way to write it besides having it like in that
It's just
uh
gonna be a fraction,
all
unfortunately.
right. So it'll always be a fraction.
It tends to be. So now the next one is -2 to the parentheses -2 power plus 1.
So would I write like
So
negative,
it becomes 1 over 2 to the power of 2
so then +1
plus 1, and then so that becomes -1/4 plus 1, which is
3/4?
3/4. Yeah.
Okay. I guess maybe late definitely like again I'd want to go over just the
Yeah.
one because I
So,
think I understand the other one very well, but
and right, and like I don't know why they give you all these different ones, but they like want to show you them early on in this course for some reason. So that's why we're doing them here. I think it's a mistake because I think there's a lot to deal with already, and you're just doing your best here
yeah.
to understand the stuff. So all right, let's see if we can graph this. Hopefully that, let me grab that graph here. So not all the stuff we did before applies to it, but we'll do the best we can here. So the points are, and I'm gonna start. Oh, I didn't write the ordered pairs. Let me do that here. So
Okay,
the
yes.
ordered pairs are
Negative. Wait, what was the way you worded it last time?
you can just say the ordered pair -2 3/4, or you can just say -1 comma 1/2, 0
Okay,
comma 0,
1
1
comma
comma
negative
-1,
2
2
comma
comma
negative
-3.
3.
Yeah. So we're going to graph these. We're going to want to graph these ones over here to the right first. So it's 2 -3, 1 -1, 0 0, and then -1, -1/2, -2. So it ends up that this thing looks like this right there.
Mhm.
Okay, it doesn't have a vertex. It doesn't have an axis of symmetry. It does have a y-intercept though. What is its y-intercept?
The y-intercept is I 0 0.
0 0. Yeah. Its domain is all real numbers. So it's that x such that x is an element of the real numbers.
All right.
It just is.
Yeah, it's just the one that's like I'm still just slightly confused on or whatever.
Yeah. This is just one of those you kind of gotta, like, when your parents tell you to do something, you just gotta do it. Like that's how
Yeah.
this is. There's not a lot of
Yeah, you just get to
um
not much say to it.
and see like you can get into like what does it mean and why and all this stuff, but like you still got to do it. So maybe just save your energy for something else that is unclear.
Yeah.
This one's a little bit harder, but it's y such that y is less than or equal to 1. Again, kind of out of scope here, so I'm not sure I want to go into why that's the answer, but we'll do that. All right, so can we, I'd like to do maybe one more example, an absolute value, if you're okay with that.
All right, I'll try that out.
All right, so we're gonna make a table here, f of x equals 2 absolute value x minus 1 plus 3. No, we're gonna go minus 4.
All right.
All right, so now I'm going to pick the values here. It's going to be,
in those like two lines, if it's negative, it becomes positive, right?
well, you do the inside part first. Okay, so it becomes, so like you're going to do, and we're going to start with the positive numbers here. So it's 2, we're going to do this 3 here. Absolute value 3 minus 1 minus 4. So you do this part first.
2. So then I guess 2, then
absolute value of 2,
-4, and then 4 minus 4 equals 0.
Yes.
All right. So then I guess.
All right. So I want you to try the rest of this table.
Okay. I'll start writing that. Yeah, I kind of remember doing something like this in class.
Yeah, and this will be our last example. We can always do more next time, but you know, there's only so much math you can do before you.
Yeah, just start to like, it just goes in one ear and then out the other.
Absolutely, yeah. You gotta give yourself a little break on it.
What's the actual line called?
It's just called the absolute value.
Absolute value. All right. Is absolute value, because I want to remember that. Because I'm pretty sure my teacher wouldn't like it if I called it the 2 lines on a test.
Yeah, the vertical bars. Yeah, they want kind of the right language on there.
1 minus 4 equals 2 minus wait, wait a sec. 2 absolute value minus 1. Okay, all right. I thought I like looked at like half of a problem or something. All right. Then 2. Oh, shoot. Okay, all right. I'm good now. All right. 1 minus 1 parentheses. And then all right, last one. All right, yeah, I got that all.
All right, so the ordered pairs are -1, 0, 0, -2, and 1, -4. I'm sorry, 2, -2, and 3, 0. So the absolute values, the absolute value function, it's always V-shaped. Okay, so it either V's up or it V's down. Okay, I'll grab that graph and we'll see which one this one looks like. Okay, so I'll just grab these ordered pairs here, -1, 0.
-1, 0.
And then 0, -2 is down here. And then 1, -4.
-4.
And then these actually come up here. So it ends up looking like this. See how it V's up?
So then I guess the axis of symmetry would be 1.
That's right. It's x equals 1.
Oh, right. X equals 1.
This one does have a vertex. It's right there. That's its vertex.
And the vertex would be 0. Oh, I mean 1, -4. Yeah.
Yeah. And then the y-intercept is 0, -2. The domain is this thing again. There's no restrictions on x. And then the range of this time, this one's different. It's y is greater than or equal to, what's the y value down here?
Um, the y value down there is -4.
So all the y values are bigger than -4.
So then that means it's going up.
That's right.
All right, so then it's going up.
Okay, so that takes us to the end of our lesson for today. Thanks so much for letting me help you here.
Yeah.
We'll do some more examples next time I meet with you. And I'll send out the notes and the screen recording a little bit later on. I'm pretty busy tonight, so probably won't be till a lot later, but check your email in the
Oh, that's
morning.
all right.
Okay, thank you, Zach. I'll see you next time.
Yeah, all right. Thank you so much.
Have a good night. Bye now.
You too.